Good day, sir. I am here today to do a video presentation of our system, which is predicting honey production using machine learning algorithms. We have here MATLAB open for our program, and first of all, we got our dataset from Kaggle, which you can see here, honey production in the USA. First of all, in order to import the dataset into MATLAB, we use the XLS read function since we are opening an Excel file actually. So using that, we are gonna open and as you can see here, it will have been opened, honey production. And here are the contents of our dataset. We have the features state, NumCol, yield per call, total prod, stocks, price per LB, and prod value, and the year it was made. Now after that, we use the cell to table function, which converts the cell array into a table for us to easily call the features of the dataset. So you can see here. And now after importing the dataset and converting it to a table, we now move on to the splitting of the dataset into a training and testing data. Now, for splitting the data, we are going to use the CB partition function, which divides our observation into k disjoint subsamples, with k being 0.2, which is the 20% testing data. As you can see here, it opens up the honey variable, which contains our data set here, which was converted to a table, and it was splitted into train test using these functions, honey, using the CB partition. Now, one thing to note about CB partition is that it splits the data randomly, and in order to control that, we use a random number generator, as you can see here before the CB partition. Basically, RNG basically to control the number generator, we used a seed of 1 and a generator of the tree fry, which you can see in the MATLAB website. Now, after splitting the data into a training and test dataset, we are now moving on to accessing the features. As you can see here, we're just calling the features of the train dataset here, the yield per call, numcall, and all of that. Same too with the test data. We're just gonna name it test in the last part of the name so that we can. Now, since we want to predict the honey production, our response variable will be yield per call, and since yield per call contains a variety of values, we are going to group them in order for MATLAB to easily predict it or create a model. So in order to do that, we did a histogram for the yield per call train. So you can see here, we are going to get the groups here. So our groups would be 0 to 20, 21 to 40, and so on until 121 to 140. And we did that using the discretize function, which basically turns the values of the column into categories or bins. So as you can see here, we did it for the train dataset and the test dataset. Moving on, for our predictors, you can see here for Y train, it is the yield group since this is the response variable. And for X train, these are gonna be our features that will predict the honey production. Now, we've done several different combinations of features, and in conclusion, this is the combination of features that got us the highest accuracy results for the models. So for the features, we have the numcall, the total production, and the production value. And the same goes for the testing dataset. We also have the numco, total production, and the prod value for the x variable. Now we also added a feature scaling in order to normalize the dataset. That was done using the normalize function of MATLAB, which is relatively easy for us to feature scale. After pre-processing the data, we then created the models to predict the honey production. First of all, we see here creating the KNN classifier model. For the KNN model, we use the function fitc KNN, and for the x value, we have the training dataset, and the y value also the training dataset. We also used a k is equal to 5 using the property num_neighbors in order to predict it more accurately, I guess. And then we started on a label KNN matrix, which predicts the model into a testing dataset, as you can see here. Then, after doing the label matrix, we then proceeded on to plot the confusion matrix, which will generate our accuracy results, as you can see on the right side. So for the KNN classifier, we had a 60% accuracy results, and the F1 score was computed using this formula. Basically, it adds both from the first row and the first column, then divides it by 2. You got the F1 score, and for the accuracy results, it's the overall accuracy of the model. Now we go to the decision tree classifier model. The same, we just use the function C3 for the decision tree classifier using the training dataset X and training dataset Y. We then made a label D3 matrix in order to predict the model using the training dataset with the testing dataset. We then plotted the confusion matrix using the plot confusion with the y-test and making the label a categorical variable. As you can see here, this is the result. We have a 72% accurate result for decision tree. Decision tree, which is actually high. The score was computed using the same formula as for the KNN classifier. Now we move on to the SVM model, which we use fitc ECOC instead of the fitc SVM, since we wanted to classify our dataset using several classes, because fitc SVM only limits us to train a class with only up to 2 classes, and fitc ECOC removes that limitation for us. So as you can see here, the training dataset and the Y training dataset is predicted with the testing dataset, which was normalized. Plot confusion was made using the plot confusion function, and for the naive-based classifier, now when we were doing the program, we had an error. Let me just remove this, and using the normal naive base. So as you can see here, if I'm gonna do a normal naive base, we are gonna get an error. As you can see here, error using classification naive base. A normal distribution cannot be fit for the combination of class 1 and predictor x1 with data at 0 variance. So in order to make our naive base classifier work, we added a different classification, a different distribution, which is the kernel. So the kernel distribution for the naive-based classifier is used for predictors that have a continuous distribution. And after that, we made the label matrix predicting the model with the testing dataset, and then did the confusion matrix again with the plot confusion. And as you can see here, wait, let me run it again. And as you can see here, it works now using the kernel distribution, but having a low accuracy level of 40.8%. Finally, summarizing the accuracy results using a bar graph, as you can see here, we inputted the accuracy results of each classifier, and we added a name to them, K and N decision tree SBM. Then bar H basically gives us a bar graph, and as you can see here, the best classifier for the honey production dataset is the decision tree. Um, Further discussion and analysis can be seen in our term project documentation, sir. Thank you for listening. I hope this is okay as a video presentation for our system. And stay safe.